Okay, this is the IPython notebook file. You download it to do the next homework. So this part is about import. Set up the notebook. Just import whatever we need. Okay. Then I create you already know lambda, you know NumPy array. This one, whatever you don't know, you look at the help on the internet. Okay. I create the data like that. Then I duplicate the data. So see, I have y plus 0.5 and y minus 0.5. I plot it. So I have x versus y, and each part have some 3 small dots, you see? So this way is how I add noise to the data. When I add noise to the data, I create a data frame. You don't need to create a data frame if you don't want to. Data frame is a Panda object. It put everything into the data frame in the table form. So data frame, data equal to something, something, something. How do you know more about this? You read Panda documentation. But for now, you just know that it made the table. By specify data equal to, what is this? Is that dictionary? Between pair and value? Between pair of value and key and value. So key is the column name. Value is the element in each column. Okay. Pair between column name and value in each column. I look at the head, the front part. I look at the tail, the back part. So that is just to show you how does a data frame look like. You can plot the data frame directly without using the type explicitly, type the pyplot, matplotlib. You can do data frame dot plot dot scatter. So you plot 2 columns from data frame. I get a plot.
Does it use Panda's own function for plotting this graph?
Is the method of Panda data frame. Of course, you will learn more by doing the homework. Okay, the homework is to go through this by yourself. I create linear regression object called LR. I initialize it with nothing. Okay, and I feed it with my data value. Okay, so to get the data from the data frame, I do .x.value. So that x is the column name. Okay, don't worry about it too much. In the homework, it will tell you what you need to know. Okay, and it will tell you what you need to try. It's not quite a homework. It's kind of tutorial to make you learn about it. Okay. So once I do .fit, it adjusts the beta, right? How is my beta? My beta equal to coefficient is 3, intercept is -7. Okay. So, okay, next part, let's do, what is SM? Okay, statmodel.api. I import it as SM, stat model. It's not just scikit-learn that can do linear regression, stat model can do it too. Okay. Stat model give me big output. Okay. In homework, you will go through stat model. Okay. Basically, I create stat model dot ordinary least square regression stat model dot os, put y and x, and I create a model dot fit. Result dot params give me the coefficient -7 and 3, which is the right coefficient. And result summary, stat model is tell me when did I do it, what is the f statistics, r square or something. That's that model. So look at what you put for the fitting. You see XSM for the stat model. It has 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So that is one of the bases, right? You can do the same thing with what scipy.polyfit or numpy.polyfit. Polyfit give me that coefficient 3 and minus 7. Same thing. Okay, it's give me coefficient, and I think minus 7 is intercept. You can do P equal to this thing. Okay, a little trick. P equal to numpy poly 1D. So this means you create poly 1D polynomial calculation based on the coefficient that you get. Okay, and I think let's skip this and you read it as homework. Okay. There is several things to learn, but we leave that for your homework. In your homework, you just run the code and explain me what you did. Okay. So different model take different amount of time. Okay. You did this already, right? Linear regression manually. Did you? We did it together, right? And I show you how to do it. How to do it is already in here. So you should not have any problem with the last homework, with the last question of the homework. Okay. Linear algebra that solve that solve system of linear equation, right? Alright. M transpose or something. Polynomial regression. How do we do polynomial regression? So this part is I create the answer. Okay, that's my polynomial. And I add some noise to it. Use uniform noise. You see that's 0 dot. So I have add some noise into it. Then I try to plot the noise with the model together. Okay. So original equation is this. If I use scipy or numpy polyfit. Scipy polyfit and numpy polyfit is the same thing, okay? It's true, same object. So, okay, look at this. I do scipy.polyfit. This part you read the documentation, okay? But basically it gives me the coefficient. Coefficient. Before the test, what you should know, okay, is numpy.poly 1D and numpy or scipy.polyfit. That's what you should know before the test. Stochastic gradient descent, L1 regularization, no, that's not in the test. But polyfit, scipy.polyfit, you should know how it works. And I showed you. You have the data, you put x data, y data, you put degree equal to 3, it gives me the coefficient. I think this is coefficient of the degree 3, degree 2, degree 1, and degree 0.
So degree is from the up to low?
Yeah, highest to lowest. That's what I think. It should be. So once you get the coefficient, you can reconstruct your polynomial, use poly 1D. Actually, you don't need to know anything. You just press Shift Tab, and it will show. Even you do it during the test, it's still fine. You just Shift Tab, and you see the documentation. You can do it, right? So, poly 1D reconstruct based on the polynomial coefficient value that you got. I plot it. You see, with noise and with exact. It's the same. Of course, you can do polynomial regression this way. Okay? But if I do it manually, oh, what's this? So if I change, okay, if you look at it closely, this is from minus 100 to 100, right? When we said it fit, it looked fit, but when I look closer, from minus 30 to 30, it doesn't fit. That is a scale. Okay. When it fit, from what? Minus 3 million to 3 million. If you look in the range of minus 100,000 to 100,000, it may not fit. So with scikit-learn, linear regression, fit transform, created to fit transform, poly.fit transform. More explanation will be in your homework. But basically when you do polynomial feature, you create this. Okay? You create the basis. That's with polynomial feature. That is with this. Okay? Homework will be, I think, take less than 6 hours. And it won't be difficult. It's just long. Okay? So that you go through this. You learn this. I do dot fit. It fit. Dot coefficient. It give me the coefficient. Dot intercept. It give me the intercept. Okay? Dot intercept. Give me the intercept. Regression with optimize.curve fit. That's several ways to do it, right? So this is just a name of function to play with. Regression with stat model, ordinary least square, give you this. Manual polynomial regression with SciPy linear algebra package. So this is a code. This is actually solution of your homework. If you cannot do polynomial fitting, so I create the basis, look like that. 1 x squared, x cubed, and then I have x transpose x, and do it. Okay, overfitting. This part is the curve that I showed earlier, right? So basically, I use a for loop to create several degree of polynomial. Look at this one. So it's like create the polynomial feature, fit transform for the polynomial feature. You won't understand the whole thing, but you will do it in homework so that you understand. So I can create this. This is test model with the test data set. So the red dot used for the test. Then I get the error, okay, R-square error. And the next part will be cross-validation score. This is a code to do cross-validation score. So I create the polynomial feature, fit transform, cross-val score, just CV equal to 5. And see what happened. Before we do cross-validation score, one thing that I want to emphasize before you go through the code by yourself is this. We do train test split first. Okay? You don't want data leak. So you remove the test data set and use it at the very end. Cross-validation score. Lasso, L1. So if you do L1, you do polynomial fit transform, you do lasso.fit, you get coefficient, several part of the coefficient equal to 0, you see? Intercept equal to that. So this way, lasso give me like better coefficient. And this is an answer from my lasso. Match pretty well, see? K4 cross validation, you can create your own CV. The object type should be K4, and you pass this CV over here. You don't need to do that. You just do 5. Okay. This one show you how to do lasso or regression. Oh, is it lasso? Blah 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 blah. With regression, start with the same thing. Get you this. Okay. So for now, you just need to know where it is. In the homework, you go here, you run the code, and you show me your result. Okay. Elastic net with regularization, just call elastic net. So basically, everything You may not know about it except gradient descent. That's the same step. First thing, do polynomial feature. Create object called poly to be polynomial feature. You specify the degree inside. Once you create the object, it doesn't do anything yet. You do dot fit transform. When you do dot fit transform, it gives you 99. If you remember, it gives you 1 and x squared. It gives you something like this. You see? If you do polynomial feature, first step you do poly equal to polynomial feature. Then poly.fit transform, it creates this. Okay? Basis 1 x squared x cubed blah 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 blah. So that's done. Then when you go to your model, depending on what model you use, basic step is you define your model. Model equal to lasso, model equal to ridge, whatever model. So this time we do model equal to linear regression. That's it. But if you want model to predict, so this one I want cross-validation score, okay? So for lasso, I do model equal to lasso. Done. Once you create your model, you can do dot fit so that it adjusts the beta value. So for regression, I do model equal to ridge. Very easy, right? You don't need to know, actually you don't even need to know what is inside. You do dot fit, it fit. It adjusts the beta for you automatically. And then you just need to know how do we get those things. Okay, dot coefficient, dot intercept. Elastic net, look, you do model equal to elastic net. Then you do dot fit. If you want it to predict, you do dot predict. Okay. Elastic net CV, cross validation. So it search for the best value of R. Okay. So this time, L1 ratio equal to that. Okay. So we have hyperparameter that we should adjust, right? So elastic net CV. Oh, why did I do that? Oh, I think something is missing over here. You see this comma? This means it's not the end of the line. The end of the line is here. So this part is the part of this line. Okay? But I should indent it. I actually indented it in the code, but here it just doesn't have enough space. So L1 ratio, instead of giving one ratio, I give numpy range 0.1, 0.2, 0.3, 0.5 into 1.1. Oh, A range doesn't include the n, right? So I go from 0.1 to 1. So basically do elastic net several times and give me the time that it gets base R squared. Okay, so it adjusts not automatically, but it's kind of automatically because I specify what is the R value. I give 10 R value, tell me which R is the best. Okay, that's elastic net. It doesn't fit. Look. So my point here is, even though the name may sound fancy, hey, I use elastic net. Hey, I use what? Ridge regression, lasso regression. It doesn't mean that it works. Don't get confused with the beautiful name. When the name look, hey, it look nice, it doesn't mean it works. Look at elastic net. It won't even fit. I even do the cross validation, like kind of grid search. Lasso CV. Give me this. If I just fit it with linear line, it would be better, right? So even though your model try to adjust the beta automatically, but if you give too many x, You say, I want to fit with x, x squared, x cubed, x to the power 4, 5, 6, 7, 8, 9. It don't know which one to make 0. It's difficult. You see what I'm saying? So you try with less complicated model first. That would be better. Grid search CV. Okay. Before you go through it by yourself in homework, let me explain a little bit. It's a little bit more complicated. For grid search CV, first of all, I create polyregress the object by myself. With this object, it can predict. So I have I take inheriting anything from the best estimator. So this way, when you create class, whatever you put in here is not input, but the prototype of the class, the base type that I take it. Okay. So I take everything from the best estimator. So it have every other method. Then I override fit. When I say polyregress fit, it call linear regression model and fit intercept equal to false, and then it do model.fit, all those things. So it fit. Predict. So I create my own object so that I put every line in just one small line. Okay? Like try to combine it. You go through it by yourself in the homework. Vandermonde matrix is the same as polynomial feature. It gives you all combination possible when you have the basis. Okay? np.vander give me just like that. And I know that it's a lot, and it's not mean for you to be able to create everything. In the homework, it's not even everything. If it's everything, it's just a lot. My point is, I give you everything, I go through it quickly, but in the homework, I emphasize just a couple things so that you can, by yourself, use this as a tool later. Okay? Poly class, regression from my poly class. Wow, it looks better. Okay. So model equal to polyregress. What is that polyregress? It is my own regressor. Right? It's my own class. I create over there. It's my own class. By the way, any reference that I take it from is here. If you click it to the original website, the code that you see here is not the same. That's it. But I learned it from there. So you can do it too. Okay? Maybe later on, not even in homework. Grid search CV is to adjust the hyperparameter. Okay? Until you get the best match. That is grid search CV. So you try to find a model that best fit with the trend data set, right? But not overfit. So are you going to, hey, let's try polynomial degree 1, give me R square. Let's try polynomial degree 2, give me R square. Degree 3, degree 4, degree 5, degree 6, and get R square of each one. And find out, hey, which one give me the highest R square. Everyone have to do this, right? But there's an automatic way of doing this already. You do grid search CV. So my model has the hyperparameter, which is degree. Degree here is a hyperparameter. If it's degree 2, it fits with degree 2. If it's degree 1, it fits with degree 1. So I don't even need to use a follow-up. I use grid search CV. Okay, without grid search CV, I get something like this. Use grid search cross-validation to find the right input, which is degree deg, right? So CV model equal to, so this is object, okay? Grid search CV, type of regressor. I put my regressor over there. Polyregress. CV equal to 5. Param grid. Okay, focus over here. Param grid here is to tell what parameter to adjust. I say, hey, adjust deg. Deg is the input, right? and I adjust in the range of 1 to 9. 1 until 9, right? So what if you do is, if you do cross validation, number of 4 equal to 5, then they try degree equal to 1, degree equal to 2, degree equal to 3, and get scoring method is R squared. So it give me, do everything and it give me R squared. And it will tell me which one give me, which deck give me the best R squared. So I do CV model.fit, give me the data, and I do CV.best estimator. It tell me, hey, the best one is polynomial degree 1, deck equal to 1, you see? So using your combination of grid search CV may be better than use lasso CV, better than use what? Elastic net CV. When you use your own CV, like grid search CV, cross validation method, this time we tell, hey, degree 1 is the best, which is the right answer. Best parameter, best estimator, the coefficient, it tell me the coefficient. And I plot. So X predict. Okay, when I plot, I have to do CV model dot estimator. What's this? Underscore, which is that. Okay, that is my model. So model dot predict give me y value. I have x input, which is x to be predicted, and y value, y pred here is a prediction. Model dot predict of x predict. So in summary, you create your object. Model equal to lasso something. Then you do model dot fit. Right? After you do model dot fit, then you can do model dot predict. 3 steps. If you do model dot predict, like this line, it use the model, which is the best fit estimator, and predict based on any input x. So these two things used to write this blue line. It's passed right in the middle. Good. Good, right? You will do it later. This one is good. Alright. CV result, that's just the detail. It tells me too many information. Okay. What about degree equal to 2? It's telling me too many things. But how do we put it into a pretty format? So CV model.CV result, very messy, like the number. So if I do data frame, pd.data frame, and that, oh, it give me the table, look better, right? It is quite very difficult, almost impossible to learn everything about pandas just in one homework. So in the homework, I don't expect you to learn the whole thing about panda data frame, but I will tell you what to use, what to do. It's like a tutorial, okay? So one more thing. Mean test score and mean train score and mean test score. So when train score go up means you fit with the train data very well. Your test score will going down. Okay. You will select the model that have maximum test score, right? So it will work best for the real world. Okay, grid search CV with third-degree polynomial. I have the data, I have the noise. Do some grid search CV, and I don't know what parameter I have, but I degree from 1 to 9. It give me this. Give me the right prediction. Okay, stochastic gradient descent. You read all this, okay? One thing is, this model is very sensitive to the scaling, so you have to scale it. The way you scale the test data, train data, must be the same way that you scale the test data. So train and test have to go through the same scaling. You don't use the test data for scaling. Okay? How do you scale it? You do. Okay, let's go to the example. I have x, it's NumPy array, y equal to 3x minus 2. Plot it, it looks like this, right? Equation is 3x minus 2. I do stochastic gradient descent regressor. I try to get the right answer. I should get 3 minus 2. Look at what I get. I don't get 3 and I don't get minus 2. I get something else. So this plot is a plot of how the beta value move from one iteration to another iteration. So when you go from one iteration to another iteration, it adjusts the beta value a little bit. So if I use the default setting without doing anything, and I keep doing it, I don't get the right answer. So this thing that I print is answer 0 minus 1, answer 1 minus 1 is like intercept and slope. So what if I set max iteration equal to 2? No penalty, eta equal to 1e minus 3. It keep adjusting and I don't get the right answer? Not yet.
Did you use max iteration just to minimize the step size?
The number of the data point that you consider in each step. How many times that I train the model? 10,000 times. So I do sgd.fit many times. Okay? But I didn't have anything about warm start. It doesn't fit. Look. Okay, this time I put warm start equal to 2. True. Warm start equal to true means take the old fitting into the consideration. I look at the data 2 at a time. I fit it 500 times. When I plot, I didn't plot the answer, but okay, this time you get 3 and minus 2. Wow! Is it wow or not wow? Yes, wow. So look at that. I did not. Did I? No. Dot fit, capital X, dot reshape, and small y. So I have model dot fit with my input x and y. When I plot about answer 0 and answer 1. Answer 0 is like intercept. Answer 1 is slope. So it adjusts the intercept and slope like that from one iteration to another iteration. So this time I have standard scaler. I scale it first before I do SGD. So I have to import standard scaler and scl.fit transform. Give me this. Okay. When I do this, it doesn't move anywhere and it gives me right answer. Slope equal to that, intercept equal to that. See? So if you scale your data first, it's faster. It go from 0 to like, you just take 100 iterations. Previously you take 500 iterations. So scale it first, make gradient descent work better. But linear regression doesn't require this. Okay? So constant, now I try to adjust the learning rate. So learning rate equal to constant. Previously I used learning rate equal to constant too. The work was the change. Max iter 300. So this time it look at 300 data point at a time. Next one is look at just 2 data points at a time. It doesn't give me the right answer. So if I use learning rate constant, this time I train more. See, when did I train more? 1000, what was the difference? But it give me a better answer this time. I think I adjust eta 0, 1e minus 3. Oh, is it same? Shuffle through. Can I find a difference? I don't know. I changed something and it performed better. Oh, optimum. Same method, just set warm start equal to true. Okay. Warm start equal to true. I get the answer. Without warm start equal to true, I don't get the answer. Okay, I get the wrong answer. So that's the key. Learning rate, other optional learning rate, I said optimal. It does something like this and it just different number of iterations. So warm start equal to true is very important. And at the end, this one is inverse scaling. So I try several kind of method. And this take less number of iteration. So there's several parameters to adjust. How do you know which one is best? You keep trying. Or you can use grid search grid search CV, set the parameter. So, and I don't think we can put this in the quiz and the homework, but maybe I try to make the tutorial for you. Basically, at the end, I split the data into several parts. Okay, split the data into several parts. And then part 1, part 2, part 3, part 4, and do incremental step learning. Maybe just take this as an example or something. It may be too much to cover everything in this course. Okay, so just so you know that with some coding and a little bit more time on doing this, eventually you can do outcall or incremental learning. It's taken me quite a bit of time too. So that's why I didn't put it in the homework. But maybe it's in the homework, but it will be quite easy. But at the end, it can do the job. With this, we just stop this thing. The regression or this machine learning, there's a lot more detail than this. It depends on what depth that we are to go through, okay? But for this course, we just show you this much. And next, we will do integration and something about ODE, PDE. And if we can cover everything else, maybe at the end, we can go back to this, okay? I think I have over the time, like 1 minute, but it's not enough for Amy because he comes 6 minutes late. Okay, we are not even yet, but okay. Thank you for coming. See you next time. Exam will cover just until this.
To lecture 7?
Yeah, till today. But most of the thing is not in there. Just polynomial feature, poly 1D, and poly fit. Those things that you should know.